Hello everyone. Today let's solve the Leetcode problem number 21. Merge two sorted lists. So basically you are given the heads of two sorted linked list, list 1 and list 2. Merge the two sorted list into one sorted list, right? So the list should be made by splicing together the nodes of the first two lists. So we have to return the head of the merged linked list finally. The example they have shown is 1, 2, 4, 1, 3, 4, and after merging into the single sorted list, we will get 1, 1. We have to get 1, 1, 2, 3, and 4, 4. Nothing but we have got 1, 1, 2, 3, and 4, 4, right? How can we achieve this? Let's see how can we achieve this, right? So in the list 1, we have 1, 2, and 4. So in the list 2, we have 1, 3, and 4. So initially what we'll do, I'll just give L1, list 1, and list 2. Initially what we'll do, we will check the initial nodes, right? We will check whether L1, value of the L1 is less than or equal to value of the L2. So this one, we are checking this one with this one, right? So whether it is less than or equal to L2. So yes, it is equal to L2, right? So we'll be pushing this one to the list, basically. So next, after pushing this one, so we will be moving this to the next pointer. So next, we will be checking this number, whether L1 is lesser than or equal to L2. So basically, it is not lesser than or equal to L2, right? We'll be displaying the lesser value. So we'll be pushing the 1 to the list and moving to the next pointer. Next, we will check whether 2 is less than or equal to 3. So yeah, 2 is less than 3, right? So we will be pushing the 2 to the list and moving to the next node in the list. Next, what we'll do, we'll be checking whether 4 is less than or equal to 3. 4 is not less than or equal to 3. So the lesser value is 3 now, and we will be pushing the 3 to the list. Next, after pushing the 3 to the list, we'll move to the next pointer. So at the end, we will just check whether 4 is less than or equal to 4. Yeah, 4 is equal to 4. Then we'll push. Next, we don't have anything. So finally, we'll just we'll just push the 4 to this one list. So we have the merged sorted list, right? Single merged sorted list, nothing but 1, 1, 2, 3, 4, and 4. So we can observe the two more things. I just want to say there are two more edge cases. Suppose if we have the value in the L1 and we don't have any value in the L2. Suppose we were having 4 and here we just had 1 and 3. So we'll just directly push the 4, the value of the L1 to the list. So in this case, we would have just got only 4. 1, 1, 2, 3, 4. Same goes with this thing as well. So suppose we had value in the L2 and we didn't had value in L4, we would have just displayed just 4. The value of L2, right? So we would have got 1, 1, 2, 3, 4 in that case as well. So in our case, the final value for this example we got is 1, 1, 2, 3, 4, 4. Here also we got the same thing, right? 1, 1, 2, 3, 4, 4. So let's continue by writing the code, right? Just give me a second. So what I'll do, initially, let's check if L1 is empty. If L1 is empty, then let's return L2, because merging an empty list with L2 results in just L2, as I have said. So not of L1, then let's just return L2, right? There is no value found. Same thing, else if not of L2, then we will just return the L1. Nothing but if we are having the value of the node in L2 but not L1, we'll be returning L2, and same thing goes with this line as well, right? Then what we'll do, next we'll check else if as I have explained, we will check the value of the L1 is not equal to value of the L2 less than or equal to the value of the L2. What we'll do, we will just set the next node of L1 to the result of merging the rest of L1 and L2. So here what we'll be checking basically is if the value of the current node in L1 is less than or equal to the value of the current node in L2, then we will just return the L1 as the head of the merge list. We will be performing this thing, or they call recursion, and finally we'll be returning the L1 if the condition holds good. If the L2 is small, then we will be returning the L2. We'll be performing the recursion and we'll be returning the L2. That's what we'll be doing. Here I'll just give L1 dot next equals, just copy this one. Let me paste it over here. We'll move to the next one as I have showed in the example, right? L1 dot next L2. Simple. Next. Return L1. We are moving to the value in the next node, and we'll be returning the L1, which will be lesser, right? Else what we'll be doing, if the L2 value is lesser, then we'll be displaying that value and we'll be moving to the next pointer, right? That's what we'll be doing. In my case, I'll just give L2 dot next equals same thing, merge to list of L1 comma, here it will be L2 dot next. Simple. We'll be returning L2. I'll just format the code and let me hit the submit. So yeah, this is working correctly, right? So what would be the time complexity and the space complexity? So the time complexity would be big O of n plus m. Why the time complexity is big O of n plus m? The function processes each node exactly once, where n is the length of L1. Basically this one, n is the length of this one, L1, and m is the length of L2. So we are having the total time complexity of big O of n plus m. Space complexity would be big O of n plus m as well. Why? The function, we are making the recursive call stack, right? Depth equal to the total number of nodes in L1 and L2 combined. So the space complexity would be big O of n plus m as well. So I'll just come here. Let me give time complexity is big O of n plus m, and space complexity would be big O of n plus m as well. So this is it. Thanks for watching, guys.